today we are going to write equations of quadratic functions based upon the graph. To start off, I would like you to identify all of the information in the box shown based on the graph. So what's the vertex? What is the y-intercept? What are the x-intercepts? Should A be positive or negative? And what should the value of C be based upon this graph? Press pause, and when you're ready for the answer, press play. So my vertex happens here at -1, -4. The y-intercept is at 0, -3. And the x-intercepts are at -3, 0, and 1, 0. A should be positive because my parabola is opening up. And the value of C is -3 because that is the y-intercept. If you put in 0 for x, you get C out. So C is -3. Now I'd like to take this information and write the equation of the parabola. And there's more than one way to do this. We're going to start with the first method where we're going to write it in vertex form. And I'll lead you through another couple ways to write the equation as well. So first, you'll notice that the vertex is at -1, -4, and I know the vertex form of a parabola looks like this. Where h comma k is my vertex. So I'm just going to fill in what I know. I know that my vertex happens at -1, -4. So y would be equal to a times x minus a -1 or +1 squared plus k, which in this case k is negative, so it'd be -4. Now I need to know the value of a, and I really can find that value by plugging in any point from my parabola, because any point that lies on my parabola has to make the equation of the quadratic true. So I'm just going to use my y-intercept here, 0, -3. If I plug in -3 for y and 0 for x, I have to get a true statement. So that will help me find a. So y is -3 when x is 0. And now I can solve for a. That's -3 equals 1 times a, or just a, minus 4. If I add 4 to both sides, I now know that a must be 1. So now I'm able to write the equation of my quadratic in vertex form. A is 1, so y is equal to x plus 1 squared minus 4. Now, if I want to get that equation into standard form, or ax squared plus bx plus c form, I can simply multiply this out. So that would give me y equals, and we're going to multiply out x plus 1 squared, so I get x squared plus 2x plus 1 minus 4, and we'll simplify, so that's y equals x squared plus 2x minus 3. Now, remember I said I would show you another way to do this. There's lots of ways to write these quadratics. So, and we have a lot of information from our graph. And I just want to show you that that can be done. If I know my x-intercepts, I know that my equation must look like this. So if -3 is a 0, x minus my 0 is a factor. So that would mean that x plus 3 has to be a factor. And based upon my other x-intercept, I know that x minus 1 has to be a factor as well. Now I can multiply that out. Or at this point, really what I need to do is make sure that I know what my value of a is. And again, remember, I can find a by using any point to plug into there, because I need it to make a true statement. Any point that's on my parabola when it's plugged into the function, will give me a true statement. Now, I don't want to use -3, 0, or 1, 0 because I use those to make my factors. So I'm going to use anything else. I could use the y-intercept. I could use my vertex. Again, any point would suffice. So I don't know. Let's try the y-intercept. So that means that y is -3 when x is 0. So if I put in 0 there, I'd get 3. If I put in 0 to x minus 1, I'd get -1. So -3 equals a times -3. Divide both sides by -3, a is 1. So now I know my function is x plus 3, x minus 1, and I could multiply that out. And you'll notice I get the same answer as I got there. If I wanted to work from standard form to vertex form, I would have to then complete the square and turn it into vertex form. Why don't we do that? So that would mean I have to add a value to complete the square. So I take my b value, which is 2, divide by 2 and square it. That's 1. So I have to add 1 to complete the square. I have the -3, and since I added 1 to balance out the equation, I have to subtract 1. So that becomes y equals x plus 1 quantity squared minus 4. And again, you can see that I get the exact same value. So really, how you do it is up to you. I generally will choose what seems the easier approach at the time. At this point, since I knew the vertex, I just simply plugged into there. I didn't want to deal with completing the square, although I did both ways. So, okay, so now let's look at our next question. It says if the value of b is 4 for the following graph, find the equation of the function in standard form. Okay, well, let's see here. What do we know? I know the vertex is at -1, -3. I'm going to do one way, and then I'll show you another one as well. So if my vertex is at -1, -3, then I know that my equation must look like this. With an a value there that I don't know. Now, I have a couple choices. I could multiply this out, and knowing the value of b, I could then figure out what a must be. But at this point, I think I'm just going to plug in another value. I know that x, my y-intercept happens at 0, -1. And I'm going to plug that in. So x must be 0 when y is -1. So that means -1 equals a minus 3. If I add 3 to both sides, I get a equals 2, which means that my equation must be y equals 2 times x plus 1 squared minus 3. Now let's just confirm that the value of b is 4. It should be. If it isn't, then this is a bad question. So let's multiply this out. X squared plus 2x plus 1 minus 3. Y equals, we'll distribute the 2. And good thing, b is 4. So I really did not need to even know b was 4 to find my equation, but it's kind of nice, and it allowed me to confirm that I did the correct, that I found the correct equation. Now, let's take a look here at number 3 and number 4. I'd like you to write these equations, write the functions for number 3 and number 4. Press pause on your video. When you're ready for the answer, press play again. Okay, so I have both vertex and standard form for each of these. And as you can see, I wrote my equation in vertex form using my vertex here. It was at 2, positive 5, and then I plugged in the point 3, 4, and I solved for a, so that was my vertex form. And then I multiplied out so that I could find my standard form. And if you think about it, makes sense. I should have an a value that's negative since my parabola is opening downward. In number 4, again, I wrote it in vertex form. So I knew my vertex was at 1, negative 4. So this was the negative 1 there, and this was the negative 2. I filled in my point 3, negative 2, and again, it really could have been any point. And then I solved for a. I got my vertex form, and then I multiplied it out to find my standard form. Okay, I'd like you to write the equations of the parabolas for number 5 and 6. Press pause. When you're ready for the answer, press play again. Okay, so again, my vertex here is at 2, negative 11. The point I happened to choose was 4, negative 3, but I really could have chosen any point, such as 3, negative 9. I wrote my equation in vertex form, and then I solved for a, and then I multiplied it out to get standard form. In number 6, again, vertex form, solved for a. I used the point negative 1, negative 3, really could have been any point, and then I multiplied it out to get the standard form. Okay, let's take a look at this problem. A quadratic function f of x equals ax squared plus bx plus c is such that the vertex is a minimum and the y-coordinate is 1. Okay, so let's just draw that. I like to get an idea of what things look like. So let's see. The vertex is a minimum, which means my parabola is going to open upward. And the axis of symmetry is negative 3. So I'm going to have an axis of symmetry there. My y-coordinate is 1, and my parabola is going to open up. So that gives me an idea about what it looks like. It asks me what the domain of f of x is, and as you can see, x really can be anything. So my domain is going to be from negative infinity to infinity. The range is different. The lowest value that I will get for my y is 1. Anything else will be more than that. So my range is going to be from 1 to infinity. It asks if a is positive or negative. It's going to be positive since my parabola opens upwards. If it had opened down, it would have been negative. Then it asks, what are the coordinates of the vertex of f of x? Well, now based upon my sketch, it really makes it easy to see what that vertex must be. So it's going to be at x equals negative 3 and y 1. So my vertex is at negative 3, 1. So y, well, let's see. My vertex is on the line of symmetry. Or axis of symmetry. And maybe I should change that. Let's see. It's on the axis of symmetry. And the y value is the minimum. And then it says, how many x-intercepts does the graph of f of x have? Well, based upon our little sketch there, it's not going to have any. The parabola opens upwards. And the minimum is above the x-axis. So there cannot be any x-intercepts. Okay, so now let's draw the graph a little bit more accurately with an extra piece of information. This says the graph of f of x passes through the point negative 2, 2. Okay, well, I know my vertex is at negative 3, 1. I now know there's another point at negative 2, 2. And I'm going to use my axis of symmetry to find another point. So I know that if I have a point 1 to the right of my axis of symmetry, I also have to have a point 1 to the left. And right now, this is about as accurate as I can make my picture without knowing a little bit more and without writing in an equation. So the next thing I'm going to want to do is write the equation of that parabola, because I'd like to know what the y-intercept is. So now I have a few points on my parabola, but I'd like to find a few more. And the way that I need to do that is to write the equation of the parabola. So I know my vertex, so I'm going to write this in vertex form. That's where h comma k is my vertex, so I'm going to fill in what I know. And now I know another point on my parabola besides my vertex, so that will allow me to solve for a, and that other point is negative 2, 2. So y is 2 when x is negative 2. So now we're going to solve for a. So solving that, I know that 2 has to equal 1 times a plus 1. Solving for a is 1. So now I can rewrite my equation using a. Y equals x plus 3 squared plus 1. Now, I'd also like to write it in standard form. This is vertex form. To write it in standard form, I have to multiply out. And I think I'll call that f of x, since that's what we're writing the equation of. So this is f of x, and we'll multiply this out, so that's x squared plus 6x plus 9 plus 1. So my standard form would be x squared plus 6x plus 10. And now, looking at standard form, I know that my y-intercept has to be 10, so I can add that to my graph. And if I'm 3 away on the right, I have to be 3 away on the left. So now we can draw in that parabola. I want you to remember that really I can find any point on my graph just by plugging in any x value. It was nice that I had the y-intercept, and that allowed me to find the other one, another point, but I could have plugged in negative 1 to find what value it was. And it looks like it's 5, but it may or may not be, just based upon the curve I drew. Maybe I was off a little bit. Let's check. So let's see how accurate my drawing is. Let's see what y is if I plug in negative 1. So that would be 1 minus 6 plus 10. 1 minus 6 is minus 5 plus 10. Oh, wow, I was really good. So I would then know that the point negative 1, 5 is also on my parabola. So again, that's just basic graphing, knowing that anytime you plug in an x value, you get a y. That is how you write the equation of a parabola based upon a graph. And now I'd like you to check the assignment online and go from there. Have a nice day.